Hello, Pre-Calc BC. Today we are going to be talking about law of sines and law of cosines. This is something that you definitely spent a day on last year in Honors Algebra 2, and then you may have done this in your geometry class the year before as well. So we are just going to be doing 5 examples on law of sines and cosines. Here are your formulas up here. A couple information for you. Law of sines you want to use when you have a matching angle and side pair, which I will get to in a minute. But one bad thing about law of sines is that it cannot be used to find the largest angle. We'll get to why in just a little bit. And then you have law of cosines. Law of cosines, there are 3 ways that you can write it, and they look like this. The key thing with this notation is that the capital letters are referring to your angles and your lowercase letters are referring to their opposite sides. Okay, so let's take a look at number 1. So number 1, the first thing that I want you to realize, and I know this is a lot of geometry here, is that you have 2 angles of your triangle, so you should be able to subtract from 180 to find your third angle, and your third angle would be 95 degrees. Okay, again, that's just subtracting from 180. So your side A is across from your angle A, your side B is across from your angle B, and 4 would be your side C. So this is what I mean by having a matching angle and side pair. You have angle C and you also have side C. This would be an example where you can use law of sines. So what we're just going to do is find all of our missing information. That's what solve each triangle means, which is what the directions say. It's kind of hiding up there. So I will start with sine of the angle I have, 95, over its matching pair or matching side is 4. And you can set that equal to sine of whatever other angle you want. So I'm going to do 45 over its side is A. And then my favorite thing, when in doubt, cross multiply. So cross multiply. Make sure you put the side in front of the sine. That's how you're going to want to type it in as well. And then we're just solving for A, so we will divide by sine 95 on both sides. And you do want to make sure that you are in degree mode, which you should be in already since we were doing SOHCAHTOA the other day, but make sure you're in degree mode. So we're just going to type in 4 sine 45 and divide by sine of 95. And we'll round to the nearest thousandth, so 2.839. And I didn't give you units, so there you go. When we find side B, which is the last thing that we need to find, ideally you do not use a rounded side to find a new side, so we are going to go back and start with our sine 95 over 4. And then I'm trying to find A, I believe. So my new angle is 40 degrees. I'm going to do sine of 40 over B. Okay, and again, I will just cross multiply. And we're solving for B, so we'll divide by sine 95. And let's see. Divide by sine 95. And you should get this, 2.581. All right, there you go. 1 down, 4 to go. Okay. All right, so this next one, number 2, is a little different. Actually, no, it's really not. JK. First, find your missing angle. You have 30 degrees, 100 degrees. That's 130 degrees, which means our missing angle is 50 degrees. I guess we should label that. Okay, so feel free to try this yourself if you'd like, and then just check your answers afterwards. I'm going to start with my sine of 30 over 6 because those are the matching ones. Okay, if you want, you can label your sides. So sine of 30 over 6, and it doesn't matter what you find next. So I'll just do sine of 50. I'll do my angle C over side C, cross multiply. So lost a degree symbol there. Okay, and then we will divide by sine 30. So 9.193 approximately. Okay, and we'll find one more. Again, you want to start with the matching pair that you know, because that information was never rounded. So sine of 30 over 6, we'll begin with that again. And this time we're going to do sine of 100 over A. Okay, so recall that I told you that you can't use law of sines to find the largest angle. We aren't finding any angles here using law of sines. We are just finding sides. So that will come into play on the other side of this as I try to cross multiply and talk at the same time. All right, so I think that looks pretty good. And now I'll just divide by my sine of 30. Six sine 100 divide by sine 30. Okay, and just, pointing this out since we just talked about unit circle yesterday, notice that when you divide by sine 30, the answer actually doubles. It's an 11.818 as opposed to a 5.901. And that's because, think about your unit circle. What is the sine of 30? The sine of 30 is 1/2, so when you divide by 1/2, you're really multiplying by 2. So that's why we have an 11.818. Yes, you do need to know your unit circle. Memorize it. Take one of the purple sheets off the side table, but know your unit circle. All right, there's law of sines. Next, we're going to do law of cosines on the back. Okay, so here are your formulas. That's what we're going to do next. Basically, we're going to use law of cosines when we do not have a matching angle and side pair. So usually that's like a side angle side situation here, or you can see side, side, side. We're not, oh gosh, what's happening? I just did something to my volume. Okay. All right, hopefully I just didn't kill your ears. So you can see you only have one angle here, as opposed to these problems, we ended up getting all of our angles. So this is generally when you're going to use law of cosines. You always want to find the side that is opposite the angle you have. Okay, so because I have angle A, I am going to use this version because that's a cosine A. So it's going to look like this. A squared equals b squared plus c squared minus 2bc cosine A. And no, you don't have to write that out. Okay, I'm just writing it for my own sake. So a squared is what I'm trying to find. My b value is 3. My c value is 4. Make sure you put cosine, not sine, and my angle is 30 degrees. So notice, what's nice about this is that you have all of your numbers on one side, so we can literally just type that whole thing in. If you want to do it in parts, you certainly can. I guess I don't need to type that in. But if you feel like it, you can. 2 times 3 is 6, times 4 is 24 cosine 30. Okay, so I just simplified it a little bit, but you can just type the whole thing in at once if you want. And cosine of 30 would be root 3 over 2, but we're going to get a decimal answer anyways. So 4.215, but please note that's what a squared is. So we will have to square root both sides. So you should get a 2.053. Technically speaking, it would be plus or minus. Okay. But as we know, we cannot have a negative side length, so we are not going to include that one. Okay. I don't know if you would really call that an extraneous solution because it still works in our equation. It's more that it doesn't work in the diagram. So I would just cross it off or not include it. I don't think you need to include the term extraneous for that. Okay. All right. So, that was just A. We still need to find B. So, oh wow, I took up all the space there. Let me fill this in, 2.053. All right, I guess I'm going to write smaller for the next problem. So one thing that I want you to notice is technically speaking, you do now have a matching angle and side, right? Like you can see that you have these guys. So if you want to now move to law of sines, you could, but you need to be careful because what I told you was law of sines can never be used to find the largest angle. Okay, here's the reason for that. It's not just like an arbitrary rule. To find an angle using sine with your calculator, you would actually use inverse sine. Okay, that's that second sine button. Okay, inverse sine, this guy right here. This is what we use to find an angle. The problem is that inverse sine, when you use your calculator, will only give you values in the first or fourth quadrant. Okay, so something less than 90 degrees, basically between negative 90 and 90 degrees. When you have a triangle, your largest angle could potentially be more than 90 degrees. Okay, it could be like somewhere over here at like a 120. Okay, so what your calculator does, if you are to put the inverse sine of, some angle and you're trying to get 120 degrees, what it will spit out at you instead is the angle in quadrant 1 that has the same sine value. Okay, remember sine is your y coordinate. So for example, 60 degrees over here is going to have the same sine value as 120 degrees. Okay, and your calculator will give you the 60 degrees instead of the 120 because your calculator will only give you an angle in these two quadrants. Okay, so long story short, law of sines should never be used on your largest angle because if your largest angle is more than 90 degrees, your calculator will not give you that answer. What that means is you should always find your largest angle using law of cosines. Okay, so my largest angle is going to be angle C. And I know that because it's across from my largest side. I have sides of 4, 3, and 2. So angle C has to be the largest angle. So I'm going to use law of cosines to find that now. And I'm just going to erase all this because otherwise I won't have room. Hopefully you wrote smaller than me. Or you could grab some scratch paper. So, okay. This time, since I'm finding angle C, I'm going to start with C squared, which is 4. 4 squared equals 3 squared plus 2.053 squared. And ideally, what you have done is you have stored that as like an x. Okay. Minus 2 times 3 times 2.053 cosine C. So here's where you need to be really careful. because your cosine C is attached to this guy right here. Okay, this is like if you had a 4 minus 2x. You can't combine a 4 and a minus 2x. Okay, so you're going to have to do this in steps. Okay, this is 16. 3 squared plus that is 13.215, and this is a little obnoxious to keep it all exact, minus 2 times 3 times x, 12.318 cosine C. Okay, so now we're going to subtract this over. (16 minus this guy, 2.785. Okay, and now we're dividing by this. Divided by that. Okay, 0.226. That is cosine of C. You still need to find angle C. So what we'll do now is second cosine, that's inverse cosine of this guy right here. And that will give us 76.936 degrees. Oh, hold up. What did I just do? This is a good learning lesson. I did a positive divide by negative, so this should be a negative. So hold on, we're going to do that one more time. It was this. Okay, divided by the negative 12.3188. Okay, negative 0.226, and now inverse cosine of that, which is very different, 103.064 degrees. There you go. So angle C is 103.064 degrees. And now you have two angles. So to find the third one, you just need to subtract from 180. So angle B, we'll do 180 minus the 30 degrees we already had, minus this new angle right here, and you'll get 46.936 degrees. Ta-da! Hooray! All right, so one more of these, and then we have a word problem, which I know you're very excited about. Number 4, what I am going to let us do this time is I'm going to let us switch to law of sines after we use law of cosines once. So again, law of sines cannot be used to find our largest angle. So we should find our largest angle, which is angle C, using law of cosines. Okay, once we find angle C using law of cosines, we will have a matching pair, an angle inside, and we can then switch to law of sines if you would like. So most people prefer law of sines anyway, so I think we'll probably do that. Okay, so again, we're going to find angle C first. So we're going to start with side C. So 8 squared equals 6 squared plus 5 squared minus 2, 6 times 5, cosine C. And we will have to do this piece by piece. 36 plus 25 is 61 minus 60 cosine C. Subtract your 61 over. Oh, that's a C, not a 6. Okay, and divide. Okay, so negative 0.05 equals cosine C. And then we will inverse cosine to find our angle. And 92.866. Okay, so now we have a matching pair and side, matching angle and side, so we can switch to law of sines. And we're only going to have to do law of sines once, because once we find one angle, we'll have two, and we can subtract from 180. So I'll do sine of 92.866 over its matching side is 8. And I'm just going to pick an angle. I'll do sine of B over its matching side is 5. And then I will cross multiply. Okay, so I have 5 sine of this angle, and I am dividing by 8. And this right here is your sine of angle B. So to find angle B, we will need to do the inverse sine. And we'll get a 38.625 degrees. So if we just think about, again, unit circle a little bit, this is saying the sine of our angle is 0.624. 0.624 is a little over a half, okay? The angle that has a sine of 1/2 would be 30 degrees. So since this sine is a little larger, we can assume our angle will be a little larger than 30 degrees, which it is. Okay? And then again, to find your missing angle, we'll just subtract everything from 180. So it's 180 minus this angle minus this angle up here, and you get a 48.509. Okay. So again, if you round things, you're going to get slightly different answers. So just be careful of that. All right, one more problem. An airplane flies from Fort Myers to Sarasota, a distance of 150 miles, and then turns through an angle of 50 degrees and flies to Orlando, a distance of 100 miles. Notice this diagram has been drawn for you, and notice that the 50 degrees is not the angle of the triangle. The plane is turning like this way. Okay, so the 50 degrees is there. First thing we are looking to find is how far it is from Fort Myers to Orlando. So this is my X. One thing I would do to find that is subtract from 180. I have a linear pair here. This inside angle will be 130. I do not have a matching pair of angle and side, so I will have to use law of cosines. So I'll say x squared equals 150 squared plus 100 squared minus 2, 150, 100, cosine 130. And I'm just going to type this all in at once. And I get this. And remember, that is x squared, so I will square root my answer and get 227.560 miles. Okay. And then through what angle should the pilot turn at Orlando to return to Fort Myers? So again, he's like going this way, and then what's going to happen is he's going to turn. Okay, so what you are really finding here is what we really care about is this angle. I know that isn't the best picture ever, but what you should notice is that my orange angle is supplementary to the inside that triangle angle right there. Okay, so since we now have a matching pair of sides and angles, we can use law of sines if you would like. Okay, so I'm going to just call this angle y. So I have sine of 130 over this 227.560, and that's going to be equal to sine of y over its matching side is 150, and I'm going to cross multiply. $150 sine 130 divided by this, and that's your sine of y, so we will need to do the inverse, and notice your sine is like a half pretty much. So we are right around 30 degrees, 30.328 degrees. But we want the angle on the outside, so we will need to subtract from 180 to get that. So your answer is 149.672. Ta-da! Okay, I hope that was very exciting. On Monday, we will actually start Polar. Get excited and have a great weekend. Actually, I think on Monday we're going over questions, and then we'll start Polar on Tuesday. Either way, you should do your day 3 homework, law of sines and cosines, this weekend. Have a good one. Bye.